More than 2, I think.
Isn't that like an asymptote?
Is that like an asymptote?
Like 2,
Yeah, it's like a limit, right?
We just did that. I'm not.
Cool? So did he grow fast enough?
Yes.
Okay, cool. So what do you think? Would this guy grow fast enough? The integral from 1 to infinity of 1 over x squared.
Yes.
Yes.
Should this guy grow fast enough?
Yes.
Why?
Because he's a higher power than greater than 2.
He's a higher power than this one?
Yes.
This one grew fast enough, right? But not grew fast enough. Approached the x-axis fast enough, sorry. Right?
Yeah.
So if that one was able to do it, then this one should also be able to do it?
Yes.
It's kind of like saying, well, I'm weaker than him, so if I could do it, then
He could do it too.
he should totally be able to do it, right?
Exactly.
Right? In theory? Does that always happen?
Big bowl of
Not really, right?
Oh my god.
But in mathematics it should, right? So let's see if it really does, okay? Let's see if it converges and what it converges to. So what would we write here?
The limit.
A limit?
B goes to
B
infinity.
approaches infinity.
Integral.
The integral.
Of 1 to b.
Beautiful.
X
X to the
squared.
negative 2.
Awesome. Let's do it. What do we do first?
First integrate.
Integrate. So what do we get?
You would get so hard to
So the limit as b goes to infinity, -1, I'm going to take them out. And we're going to get x to the -1.
Yes.
Ah, evaluated from where to where? 1 to b, right? And we want the limit of all that. Cool?
Yeah.
Yes, no, maybe so?
Pretty lit.
Alright, so I'll plug in the b. What do we get?
1 over infinity.
1 over b
Oh, sorry.
minus 1 over 1. And we want the limit as b goes to infinity of all that. So now we got -1 times. What happens if I were to approach infinity for b?
It will go to 0.
We'll go to 0, so here we get 0 minus 1. -1 times -1 is 1. So this guy converges towards 1. Do you agree? Awesome. So he grew fast enough for sure, right? I keep saying that, grew fast enough. Approach the x-axis fast enough. Yes? Another one?
Yes, sir.
Another one.
Yeah.
Alright, let's see if we can fit it in here. Do the integral from 1 to infinity. If you can't, just find somewhere else on your notes to fit it in, right? Or your notes. That's the beauty of it. Or if you don't even want to write it down, don't write it down. Some of you just like to listen. But every choice we make in life has a consequence.
Of course.
So this is the limit as what?
X cubed.
X cubed, yes. Sorry, I didn't say it. 1 over x cubed. So should this guy converge?
Well, maybe. Yeah.
Why?
It's a higher power.
It's a higher power than that one, right? And then that one, and those two converge, so this guy should also converge, right? Those are weaker than him, and they can do it, so he should be able to do it?
Maybe sure.
Theoretically, okay, let's see. So this would be the limit as b approaches infinity of the integral
1 to b.
1 to b
X to negative.
x to the -3 dx, right? Alright, so let's do it. Integrate him real quick. Real quick.
Negative 2x, -3. I'm just
What?
negative half.
Come on. Negative half?
Negative half.
Oh, so -1/2, put him a little bit separate from him, right? So -1/2 x to the -2. Just kind of put a parenthesis between the constant and the thing, right? You kind of already write it on the outside. Evaluated from where to where? From 1 to b, and then what do we want of all of that? The limit, and you have to write it. You don't write it, you're going to get it wrong. You haven't taken the limit, so you can't stop writing it. Alright, so what do we end up with here? The limit as b approaches infinity of -1/2 times. What do we get when we plug in b? 1 over b squared, right? Minus 1 over 1 squared. Okay, so let's evaluate it. So really all we're looking at when we do the limit is this guy right here. Right? What happens if I put infinity squared there?
Infinity.
Infinity, right? We said it was a perfect square. And then 1 over infinity, 0 again. So negative half times 0 minus 1. What do we get here?
You get positive.
Positive half. Why is it getting smaller?
Because it's going faster.
Huh? Because the denominator is getting bigger?
Yeah.
Okay, but in theory, why is that area, that bounded space decreasing?
It's going faster towards the x-axis.
I'm getting closer to the x-axis faster, right?
Yeah.
So the amount of space that I can accumulate is decreasing, right? It's smaller, right? And it's getting to its limiting value faster because I'm getting infinitely close to it sooner. Does that make sense?
Yeah.
Yeah? So I'm getting to the point where I'm like technically adding nothing sooner.
Yeah.
I'm getting closer sooner.
Yeah.
Ah,
Wow.
that's awesome, right? So this guy converges towards what? Towards 1/2. Okay, cool. So do you notice any pattern here? What do you notice about each of these functions? Are they all kind of written in the same form?
Yeah.
Yes? What form are they written in?
1
over x.
1 over
1 over x to the n. Okay, cool, I like that. I want to use a different letter though.
B. I'm just kidding.
1 over x to the... What would be a good letter to use for that exponent?
X.
What's another word for exponent?
Power.
Power!
Oh.
So could we use like a p?
You.
Yeah? Does that look familiar one? 1 over x to the p?
Is it gone? Are you into calculus?
Yeah?
Is he born or what?
What is that similar to what?
Huh?
1 over x to the p.
What is XP? I'm just kidding.
Harmonic series?
It's gone.
Well, if 1 over x, so p series.
P series. There you go, makes sense, right?
Haha.
1 over x to the p
P.
series.
Get it? P
Cool.
series?
Good. I'll give you some bathroom humor in a little bit.
Wait a minute.
Okay? Hold up for that joke, okay? I mean, I gotta be real on the camera, right? I can't fake it. We're not gonna pause it, say the joke, and then start it.
But we can edit it.
Alright, anyways. Good? So that's the way of mathematically working out any improper integral where you notice that it has an infinity as an upper bound. It would be the same approach if the infinity was the lower bound, okay? You just change the letter, right? Instead of B, it would be what? A. It would still work it out the same way. Now, these three problems are all in the same particular form. The reason I'm doing that is because later on when we do series, we're going to talk about this particular type of series, which is a P-series. Okay, and there's actually a P-series test, and then we get into all that good fun stuff. So kind of already getting a glimpse of what we're going to do when we do sequences in series, and we're able to actually do them through here. Okay, now this could be a problem on a multiple choice. You get something that kind of looks like this, you'll be able to answer the question really quickly. You have answer choices that say converge to a number, or you have answers that just say what? Diverge, right? If you're able to recognize that it's something in this form, okay, what I'm going to show you next is going to help you to answer that question that much faster. Okay, but before I go there, let's see if there's any correlation between the power and the answer. Okay, because there is a pattern, but I don't know if you guys can recognize it. Let's write it down. What was the power of this guy?
3 over 2. Oh, I see.
So the power was 3 over 2, and the actual integral was what?
Something.
Was 2, right?
Oh, yeah.
What was the power on this guy?
2.
2, and the actual integral?
What's the I stand for?
1. The I is for integral,
Wait a minute.
kind of like the value of the integral.
I'm
What was the power of this guy?
3.
3, and the value of the integral? Half. So somebody in the other block was able to figure out the pattern. I don't know if you guys
We
can.
can do it, we can do it, we can do it.
See if there's a relation between the power
It says pi.
and
3
the
over
value
2,
that we're converging towards.
3 over 2, 3 and 2. What?
Yes.
Because if you do that, like, never mind, no.
How could knowing this help me find this? Because I don't want to have to do all this work. I want to be able to go from that, boom, to that. Think of like that.
Oh.
Oh no. I'm not smart.
And all of these are like P series that are converging. You guys don't like puzzles?
We like
Really
it.
don't.
Got him.
Is
It's
it,
the number in.
is it inversely proportional?
Inversely proportional, what do you mean by that?
Like as in,
So what would you do?
well, it's just that it increases by like 50%, but the integral decreases by 50% at the same time.
Okay, but pretend you don't know the answer to the integral, okay? Because when you're given a problem, all you're gonna know is what the power is. So how can you go from knowing that number to knowing these numbers?
It's the coefficient on opposite side.
Can't think about it?
No, yeah. It's
Give us the whole block.
It's
not
If you divide 2 by 2,
you get one.
You
You
just
just
integrate
integrate
it
it.
to
You divide 2 by 2, you get
Huh?
one. The sound of 2
Because that's what we need.
It's just the coefficient of it.
Huh?
Can you say it loud?
I never
There is some dividing, and there is some subtracting.
So there's.
No, it's one that plus one.
Yeah, I got it, yeah.
Let's
Oh,
see.
Tristan, it's say it.
Checking?
Tristan,
Yeah.
please say it louder.
Almost.
Almost? Alright, want me to give it to you?
No.
No?
till we die.
Don't say it until the end of the block.
Don't say it?
Until the end of the block,
I
yeah.
have to say it.
Oh, what? That's impossible.
Do it to him.
Alright, well,
No.
Wait.
We're failures.
wait. You got it?
It like, above the, like right here,
Uh-huh.
like there's a -1, and it's 1. Oh, no, 1 over -1 over 2, and then it becomes 1 over 2.
What do you notice about all these?
Oh my
Negatives.
Come on.
They're all times negative.
They all have a 0.
Huh?
They're all,
It's all times
it's 0 minus 1, 0 minus 1, 0 minus 1.
But we're not
It's
supposed
whatever.
to. But we're not supposed to know that yet. Because science said that we need to figure it out with just the power.
Right.
Yeah, that's why. But just the power.
So
Whenever you.
all you know is that the power is 2. How do I go from knowing that to knowing that the answer is 1?
Yeah.
Without doing any of this.
Bro.
Because. I don't know.
Put the answer on top.
Oh! I want to say something.
I'm close to
I
something.
feel like that requires the word. But you can do it mentally. Because you can recognize that, say,
Number
X-
sense, right?
not numbers.
Wait.
You recognize that.
Alright, well let me help you. I help you a little bit?
No.
Alright, so all of these problems, okay, are what we could call P series integrals. And the reason we can call them P series integrals is because they're in that form, 1 over x to the what?
To the power.
1 over x to the p, okay? And that's kind of related, or it is related, to the power series that we're going to talk about later, eventually. Cool? Alright, so there's 2 cases whenever you're integrating problems like that from a number to infinity, okay? In all the examples we did, what was the number that we started from? 1, okay? It could actually end up being another number. So if a is anything greater than 0, doesn't have to be 1. If it's 1, it's awesome because we can use the shortcut to get the answer. Okay, but if it's not 1, well, we're going to know if it converges or diverges at least, but we're not going to know what it equals unless we actually do the math. Okay? So if a is greater than 0, then we can know whether this integral from a to infinity, whatever that is, okay, that's if it's not 1. It could also be 1, okay? We're just kind of lucky when it's 1, because we can get the answer real fast. But anything greater than 0 to infinity, something written in that p series form, 1 over x to the p, we can say is convergent if p is what?
Greater than one.
Greater than 1? When P is greater than 1, very good. When would it be divergent?
Less than one.
Just less than 1?
And greater than negative.
Could it be equal to 1?
Yes.
If less than or equal.
Yeah? Is that the very first example we did, that 1 over x to the first?
Yes.
That one was divergent, do you remember? Yes or no? I can flip it back so you can see it. That was the one we did yesterday with the calculator?
Yeah.
Yes? So it seems to be here that P series is dependent on the number what? 1. P series is dependent on the number 1.
Oh, that's the bathroom.
P series is dependent on the number 1.
Number one.
You pee number one.
Okay? P
When you pee.
number 1.
When you pee is number one.
Yeah? Somebody get it?
Yeah.
Not poop, okay? That one's dependent on number what?
2.
2, yeah, okay, cool. So that was my bathroom joke.
That was pretty funny.
That was pretty good.
You like that one? Hopefully that'll help you remember. P series is dependent